Hey everybody, today we're going to be discussing how to do inequalities as well as solving systems of equations and how to solve for x and y, and also how to tackle some word problems. And we're going to be breaking everything down step by step, starting with the basics, moving into different solving methods, and so get ready and let's get straight into it. Alright, so there's a couple of cases we can have when we have a system of equations. So we're going to have two lines, right? So you can have a linear quadratic equation. Well, not necessarily, but a linear quadratic equation. And what this looks like is when you have your x and y axes, you're going to have a parabola, might look like this, and you're going to have a line going straight through this. So there are a couple of cases we have to consider here. So this case is going to give us two solutions. And there's going to be another case where your linear and your quadratic. So let's say this is your quadratic here. And they're not even going to touch. So maybe it'll look like something like this. So this would net you 0 solutions. So, right, 0 solutions. And then we're going to have one last case where you have the quadratic and then you have your linear line, but it touches right at the vertex, which is going to give you 1 solution. Alright, so now with quadratics, it's going to be a little bit different here. We can have a total of 4 possible cases overall. So we can have a quadratic that looks like this and intersects right at, so the point where they meet is going to be right at the vertex. So that's going to be 1 solution. Okay. And then we have another one where they create a sort of Venn diagram looking shape. And that is going to give us 2 solutions. And you have the third one where they just completely miss each other and never even intersect, netting you 0 solutions. But there is one last thing that we need to consider. There's also a 4th case where you graph the line and the system overlaps itself, meaning that it creates 2 of the same line. And in that case, we're going to have infinite solutions. So that is how we're going to be looking at these quadratics. I mean, that's just what they're going to be looking like. And we can determine the amount of solutions by graphing it out and looking where they and how they meet up with each other. So yeah. Diving straight into this. Alright, so starting with this question here, we are asked to graph the following systems, and we're going to be labeling the solution. So I'm just going to begin by solving algebraically here. So we're going to skip straight to 2 here. And so let's solve this. So if we were to solve this algebraically, we have this system of equations here. My minus 2x minus 3 equals minus 3 equals 0. And then you have y plus 5 equals 3x squared. Okay, so you have this little systems here. And what we can do is we're going to solve this now. So I like to do substitution personally, but we can start off let's start off doing substitution. So the way we do substitution, typically in quadratic systems of equations, is you're going to isolate for your y variable in one of your equations. So you can either isolate for y here, or you could isolate y in the other one. But I'm going to isolate y in the first equation. It doesn't matter which one you do, because you'll get the same end result. So To isolate y here, what I can do is I can add 2x to the other side and add 3. So I get y equals 2x plus 3. And now that we have our y isolated, so this is going to be our first step, we're going to go back into our other equation, and we're going to plug it in. So we have what y is equal to. So y is equal to 2x plus 3. And we're going to replace this y. So we have 2x plus 3 plus 5 is equal to 3x. So that's just our general equation, but with this instead of the other y. Okay. And now what we can do is we can just remove these brackets, and we have 2x plus 3 plus 5 is equal to 3x squared. And we can just collect like terms here. So we get 2x plus 8 is equal to 3x squared. Alright, and now I'm going to subtract 3x squared to bring everything to one side. So you get negative 3x squared plus 2x plus 8 is equal to 0. So now what we're going to do is we're actually going to solve for x. So let's look for our x value here. So let's try factoring. So two numbers that multiply to negative 24 and add to give us 2. So we could have let's say 6 and negative 4 and 6 and negative 4. So we're going to break this middle term down into 6 and negative 4. So we have negative 3x squared, and then we have our new plus 6x minus 4x plus 8. So you can group these guys up in brackets, and you can factor out whatever's common between the two. So there's a common negative 3x actually in the first bracket. So factor out that 3x, and you get x plus, or x plus 2, or should be x minus 2. And then in the second bracket, there's a common 4 that you can factor out. So you get negative 4, and then x minus 2. So these two brackets should match up whenever you're doing factoring and decomposition. So once you see that they match up, you know you've probably done it right. So then we're going to get negative 3x squared, or sorry, negative 3x minus 4 and x minus 2. And then we're going to set this equal to 0. This goes back to your guys' last unit where you're just solving and trying to find x. So in this case, we're doing factoring. So we're going to set each individual bracket equal to 0. So we have negative 3x minus 4 is equal to 0. And you get negative 3x is equal to 4 when you add it to the other side. Divide it by 3, and you get x equals negative 4 over 3 as your first solution of x, to be noted. And then we have x minus 2 equals 0. You add 2 to both sides, and you get x equals 2. So basically, from this part, you should be getting x is equal to negative 4 over 3 and 2. Whatever way you did it, you could have used quadratic formula. You could have completed the square. I just happen to do factoring here because it's what is the easiest for me. So now what we can do, you have firstly isolated your variable, plugged it in, so we're just solving for one variable, which is x. And since now that we've found what x is, we have to go back into our equations, both of them, and plug in our values of x. So typically we're going to plug our value of x in the equation we haven't used yet. And what I mean by that is we haven't done anything with this equation except isolate for y. We've actually used this equation to solve our quadratic. So what we're going to do is we're going to be using the equation we haven't used, so this one right here. So we're going to plug our x values in. So we get x is equal to 2. So let's plug in 2 into here. So we have y minus 2 times 2 minus 3 is equal to 0. So now you have y minus 4 minus 3 is equal to 0. Collect like terms, and you get y minus 7 is equal to 0. Add 7 to both sides, and you get y is equal to 7. So what's different from this unit than the last is you're actually going to express this as a coordinates, because so you have what x is equal to and where y is equal to that x as well. So we're saying x at 2 gives us a 7, and that is one solution to our system. Another answer to our system here is going to be the other solution. So we got x is equal to negative 4 over 3. So let's go back and plug that in. So x equals negative 4 over 3. And you get y minus 2 times 4 over 3, or negative 4 over 3, minus 3. So I'm just going to put that all on my calculator. So we get negative 2 times negative 4 over 3 minus 3. And that gives me negative 1 over 3. So y minus 1 over 3 is equal to 0. And now I can just add 1 over 3 to both sides, and I get 1 over 3 is our y. So basically, when x is equal to 4 over 3, our y is equal to 1 over 3. So let's put this as our coordinate. So negative 4 over 3, comma, 1 over 3 will be our final solution. So these two solutions are going to be the answer to our equation, and that's how you do it using substitution. Alright, so now we're going to be doing solving by using elimination. So to use elimination, we typically stack up our two equations and then subtract from each other. So the way we're going to do this is we're going to isolate for y, because we have a quadratic here. If we isolate for x, it's just going to result in a mess because we have two x's that we got to consider. And let's just do y. So y is already isolated in our first equation, so we don't have to do anything. But in our second one, we have to isolate for y. So the way we can do this is I'm just going to subtract x squared here, and then you get negative y is equal to negative x squared plus 2x plus 3. And then you divide everything by negative 1 to isolate y on its own. And y is equal to x squared minus 2x minus 3. Okay. So now that we've got our y terms lined up, all we need to do is just write our equation above it, our original one. So we have 3x squared minus x minus 4. And you're going to notice how everything actually lines up real nicely. So we have y over y, x squared over x squared, x over x, and our constants over our constants. So all we can do is just look at our y values. So we have an invisible 1 in front of both. So if we were to add them, that would give us 2y, which is not what we're looking for. So we're going to subtract here. So y minus y gives us 0, then 3 minus 1 here is going to be 2x squared. And then you have negative 1 minus negative 2. Remember, these signs cancel out. And you have negative 1 plus 2, which is just going to give us positive 1. And now you have negative 4 minus negative 3. So negative 3, or negative 4 plus 3, gives us negative 1. So now I'm going to solve for x. You can use any method, again, complete the square, quadratic formula, factoring, whatever works best for you, as long as you find x. So I just want to show you guys how quadratic formula is going to work out. So I'm going to use the quadratic formula. So we have a, b, and c here. And your quadratic formula is going to be negative b, which is 1, plus or minus square root, which is b squared, which is 1, times 4 times 2 times negative 1. all over 2 times 2. So once you simplify, this should give you -1 plus or minus the square root of 9, which is 3, all over 4 is equal to x. So now we can find our two solutions. So we have the plus one, so let's do -1 plus 3 over 4. That gives us -1 plus 3 is 2 over 4 equals 1 over 2. So one of our solutions is going to be 1 over 2. Now let's try the other solution. So -1 minus 3 over 4. That gives you -4 over 4 equal to -1. So you have x is equal to -1. So now we found our two solutions for x. All we have to do is we're going to substitute our values back into one of our lines. And what that's going to look like is this. So we have x squared minus y. So you got to look at both of your lines, okay? At this point, when you've done elimination, it doesn't matter which one you plug it back into. You just have to look and see which one's easier for you to substitute back into. So personally, I don't like how this one has like separated by two sides. So I'm gonna plug it into our thing here, our first equation. And remember, when you're doing this, you're using the original equations, not the ones that you've manipulated down here. You're using the original ones that are included in the question. So we have 3x squared minus x minus 4 is equal to y. And if our x is equal to -1 and x is equal to 1 over 2, let's see what y is going to give us. So we have 3 times -1 squared minus -1 minus 4 equals y. So all you can do is you can just like plug this into your calculator. So let's do this here. So we have -1 or sorry 3 times -1 squared minus -1 minus 4. And that's going to give us our y. So y happens to equal 0 here. So at -1, our solution is going to be 0. So now let's test out the other solution. So we have 3x squared minus x minus 4 is equal to y. And we have x is equal to 1 over 2. So now we're just looking for y where x is equal to 1 over 2. So let's plug it in. So we have 3 times 1 over 2 squared minus 1 over 2 minus 4 is equal to y. So I'm going to plug all of that into our calculator here. So it should look like this. That gives us an answer of -15 over 4. So at where x is -1 over 2, or 1 over 2, you get an answer of -15 over 4. So these are going to be your two solutions, and that's how you solve by using elimination. And the way you check this again is you're going to plug in your solution into your first equation, your other solution to your first equation, this solution into this equation, and this solution into this equation. But to spare some time here, we're not going to do that. But if you did, it would give you left side equals right side, which is what we're looking for. So now we're going to be doing some inequalities. We're going to be moving on from our systems of equations. So let's take a look at how to solve these inequalities here. So there's a couple things you want to know when you're doing inequalities. Whenever you multiply by a negative number, your sign will flip. Or whenever you divide by a negative number, your sign will also flip. So just make sure we're keeping track of that and not getting lost with that. So here we have an or equal to sign. So if we have an or equal to sign, that means we're going to have a closed dot. And if we have an open dot, that means less than or this. So we're going to be having a closed dot on our line here. So let's just solve for our isolate for x here. So before x, and you're going to subtract 5 from both sides. and gives you is less than negative 12. Is less than negative 12. And you're going to divide both sides by 4. And since we're not dividing by a negative, we can keep our sign to be the same. So now we get x is less than negative 12 over 4, which is just going to give us negative 3. So x is less than or equal to negative 3. So let's say this is 0, and this is 1, 2, 3, negative 3. So any number with an open dot, since we have an or equal to sign, or a closed dot, since it's or equal to sign. And we're just going to shade anything that is past, or sorry, yeah, anything that is less than our negative 3. So we've expressed our inequality here. So we're saying that anything that's less than x or less than 3 is going to be true in our inequality here. So now let's do this. So personally, we have this time we have a greater than sign with no or equal to on the bottom. So we have an open dot here. And now we're just going to isolate for x. So I'm going to divide both sides by negative 2. You can get x minus 10 is less than 8. Now what we can do is we just add both sides, or add 10 to both sides, and you're going to get x is greater than, or x is less than 18. So now let's just say this is 0, and then this was 18. So x has to be less than our 18 here. So we're just going to shade anything that's less than 18. And make sure you're using an open dot here, since we don't have any or equal to. So just use that or open dot here, and you should be fine. That is how you express this inequality. Alright, now, so what we're going to be doing is graph and label each of the following inequalities. Shade the true region. So there's two parts to this. We're going to be finding our inequality and shading the true region. So normally when we're graphing lines, we have a y equals. So in this case, we have to ignore the sign and pretend it's a y equals in order to graph it. So we have 2y is equal to 3x minus 4. And you're just going to divide everything by 2y to isolate for y. So you get 3 over 2 x minus negative 4 divided by 2 just gives you negative 2. So let's plot our point. So our y-intercept is negative 2. And let's graph this now. So we have a rise of 3. So we're just going to go up 3. 1, 2, 3. And then right 2. 2. 1, 2, 3. 1, 2. 1, 2, 3. 1, 2. So now you have this line here. So I'm going to draw a point that kind of connects all of these here. And it should look something like that. So now the way you actually shade the inequality is you're just going to look at the sign, right? So we have a greater than or equal to sign facing towards y. So y has to be greater than or equal to whatever this equation gives. So I'll show you what this kind of looks like. So the way we do and solve this is we use a test point on the graph to determine whether it's either false or true. And if it's true, we're going to shade. If it's false, then we aren't going to shade. So I'm going to show you what this kind of looks like here. So let me just move this over here. So I'm going to use I like to use the test point 0, 0. And if we have 0, 0, it's going to be above the line, okay? So we're going to see if it's true or false. If it were true, then we're going to shade everything above this line here. If it were false, then we shade everything below the line. So let's just try this. So we have 0 is greater than or equal to 3x times 0 minus 2. Now we get 0 is greater than or equal to negative 2. And since 0 is greater than negative 2, this is true. And if it's true, that means we're going to shade everything above this line. So to shade it like this, should look something like that. And that is how you express your inequality. So now you have your equation, and should be good. But there's one last thing I forgot to mention. With this sign here, we have an or equal to sign. If we have an or equal to sign, we have a solid line. But if we have a dotted line, then it's just a less than or greater than sign. So those are the things you want to kind of identify before you graph the line. So I'm going to show you how we're going to do this here. So here we have a quadratic, so it's going to be a little bit more tedious to graph. But let's just ignore this to solve and graph our line. So we have y plus 12. And we're going to set that equal to x squared plus 4x. Now I'm just going to subtract 12 from both sides. You get x squared plus 4x minus 12. And now this is in its graphable form. So you can go in your calculator and just type this out. So we have x squared plus 4x minus 12. And I'm just going to find our intersection points here. Our zeros in this case. So let's just find our x-intercepts. So we go intersect, and then we just find our zeros here with our graph. So we get our zeros as so as x equals 2, 0. And let's find the other one. And this one looks to be about -6. So we get -6 and 2 as our things here. So let's just make a scale of -8, 8, 8, and 8. So if our parabola looks like this, we have our -6, so it should be about right here, and 2 should be about right here. So we can have a parabola that kind of looks like this. Kind of looks like this, but it should go more below the line here, so I'm gonna fix this. Parabola should look like this. Okay, something like this. You get the idea. It doesn't have to be fully accurate here, but we're just kind of graphing it out to see if it's like above or below the line. So now that we've done that, what we're going to do is we're going to test our shaded region, our true region, as one would say. So again, since we have a less than sign on its own, that immediately means we're going to have a dotted line here. So whereas the last one we had an or equal to sign before. So we had a straight line, but in this case we have a dotted line because it's just less than with no equal to sign on the side. So let's make this line dotted. Here, let me fix this real quick. Junk. Precision. So I'm just gonna make this dotted. Good enough, I guess. Let's make this a dotted line. And there we go. Now we can actually find our inequality. So we have y plus 12 is less than or equal to x squared plus 4. So if you were to do 0, 0, this point would be in between or in the middle of our parabola. And if we were to do a point outside of it, it would be outside. But don't pick a point that's on the line. Pick a point that's definitively either above or below the parabola. And in this case, in the other case too, make sure you're picking a line that is directly above or directly below, not on the line. Because if you pick a point on the line, that doesn't tell you much. You can't really pick a shaded region. You have to pick one that's above so you can know where to shade. So we have 0, 0. And 0, 0 is going to be above our line here. So let's just plug in our 0. So we have y plus 12 is less than or equal to x squared plus 4. And we have 0, 0. So we have 0 plus 12 is less than 0 squared plus 4. 12 is less than 4. Is this true? 12 is not less than 4, so we have a false. It's going to be false. And since this is false, we're not going to be shading inside the parabola. We're going to be shading outside. So let's just shade outside. And that should look something like this. So you have a dotted line, and your parabola is going to be shaded on the outside. And that's how you actually graph inequalities. So there's one more thing I want you guys to know. It's that you can actually graph these inequalities built into your calculator. So what I mean by that is the last equation we got was y is less than 2 x squared minus, let me just check it real quick, x squared plus 4 minus 12. So the way you actually graph this is these signs can be synonymous with each other when you're using your graph, but make sure you're dotting your line instead of this. And this, so this would be a straight line and this would be a dotted line. Just make sure you're remembering that. So let's say you have this. Y is less than or equal to. So your y has to be on the left side. Like, you notice how when you're using your calculator, when you're graphing, your y is usually on the left side to actually plug it in. So if we go here, our y is on the left side of our calculator. So since it's already done this for us in our equation, this is gonna be really nice to graph. So the way we graph a less than symbol is we use this bottom triangle here. And you can remember this as less than being below the line. So in this case, pretend there was a line here and this would be below the line. So the little triangle shaded in the bottom is equal to y is equal to less than or equal to, depending on what you're looking for. Just remember the dotted line and the straight line differentiate these guys. So now let's actually try this. So let's plug in our equation as if we were going to graph this normally. We have x squared plus 4x minus 12. And if you graph this, this should give us this U-shaped parabola here. And now we're going to actually apply what we have here. So we have this little, so the way we do this is we're just going to go over and we're going to hover over our y. So you're just going into your y equals, and you're just going to go all the way over on the left with your arrows. You hit enter and you go to line and you just adjust until you have this little triangle in the bottom, which is significant of less than. Press enter and then you hit graph. And then do you notice we graphed this exactly in the last equation where we shaded outside of the region? So this actually graphs the inequality for you and it's built in. So this is not cheating or anything. This is some calculator knowledge that you can apply whenever you're graphing an inequality. So I want to test this with the linear one as well. So we had 2y is greater than or equal to 3x minus 4. Okay? So the way we do this is we just divide everything by 2, and we get y is greater than or equal to 3x minus 4. Or 3 over 2x minus 2 is our line, okay? So let's just plug in our line here. So we have 3 over 2 x minus 2. So normally you would be graphing it like this. Ignore the shaded region because we used the last one. But this one is going to be different. Remember that we actually graphed last time using our less than. And since this is y is greater than, this time we're going to be using this upper triangle, which means that it's going to be above the line. So y equals is above the line. So let's change this. Let's press enter. And then let's go above the line this time. And if you have older calculators, this still works, but there's not gonna be like a interface for this. But instead, you're just gonna have to press enter on the leftmost of like y until you get this little triangle thing that pops up. So we get this. So it's shaded above the line. And if you remember, we did this earlier and it was also shaded above the line. So this helps you kind of double check if you did your equations right. But again, remember that ultimately it comes down to this or equal to sign, whether you have a straight line or a dotted line. But this is just a way you can check. So just remember, in summary, we just have our y equals, our y is greater than, or y is like this. We're going to be using our upper triangle. But if y is less than, or y is less than or equal to, we're going to be using this lower triangle to graph that. But there are some implications that come with this, right? So for example, let's say we have x squared plus, or x squared minus 9 is greater than or equal to y, okay? So what we're going to do here is we are going to have to move our y to the left. So the way we do this is we just have to flip the sign. So we have to do y is less than or equal to x squared minus 9. And you're just rewriting it so that the y is on the left. Because if you did this, this would be very confusing when using this kind of method. So now we have a clear definitive thing. So in this thing, it says y is less than x squared minus 9. And then this one is y is less than x squared minus 9. So it's the same thing. You're just rewriting it left to right. And let's just do this. So y is less than. So we're just going to be using this bottom triangle here. Remember? Or equal to x squared minus 9. So just plug this in your calculator. It should look like this. X squared minus 9. And we're going to be using the bottom triangle again. And hit graph. So what this tells us is when we're graphing this, it'll be everything that's below the line, which will give us our solution. So when you graph that out, it should give you an equation that looks like this. So that is the way you actually graph inequalities in your calculator and make sure that you're graphing them properly. The only thing that this thing doesn't do, again, is it doesn't do the straight line or dotted line for you. That's something you have to analyze yourself. But again, just remember, straight line is or equal to, and the dotted line is just anything else. All right, we're going to be moving on. We're going to be doing some case analysis now. So I want to do case analysis before I do roots and test points, just to make sure everything's all swell and good. I just prefer doing case analysis. All right, so we have this equation: 4x squared minus 19 or plus 19x plus 5 is less than or equal to 0, and we're going to solve this using case analysis. So how do you actually do this, right? So the way we do this is we're going to look at our sign to begin with. Remember that it's a less than or equal to sign, and we're more so looking at what this actually means. So during case analysis, you're always going to have an equation, and it's going to be less than 0. Typically, you're going to isolate everything, so it's less than 0. So in this case, we have this equation, which is less than 0. To be less than 0 means to be negative. So basically, this equation is going to be negative. Okay? You're like, probably wondering, like, what does that mean? Like, you know, to be negative, like, what are you talking about? But I'm going to show you what that actually means. So we have this equation is less than 0, which is negative. But if it were greater than 0, then that would mean it's positive, right? So let's just break this down first. So I want to factor this. So we have 4x squared plus 19 plus 5. So let's just break this down. So we have two numbers that multiply to 20 and give us 19. So I think we have or sorry, this should be minus 5. I wrote this equation wrong. Ignore that, ignore that. So two numbers that multiply to give us negative 20, but add to give us 19. So we have the numbers 20 and negative 1, 20 and negative 1. So we're just going to be splitting our middle term again, so this is just decomposition. This gives us plus 20x minus x minus 5. Okay, so now let's group these two up and factor out what's common between the two. So we have a 4x that we can factor out from the first one. You get x plus 5. And then you have a negative 1 that you can factor out from the second one. You get x plus 5. You group these two up and you get 4x minus 1, x plus 5. And let's set this equal to 0 so we can just find our roots to begin with. So all we're doing is first step of case analysis is finding the roots. So we have x is equal to negative 5 and x is equal to 1 over 4. Okay, now that we've found our roots, we can start doing case analysis. So case analysis is just saying, remember, we have our negatives, right? We have our whole equation, and it's going to be a negative outcome because we have it less than 0. So what does it mean to have a negative number? Remember that we have two factors, right? We factor this down into two factors. When you're multiplying two things together, what gives you a negative? So case 1, you can have a positive multiplied by a negative to give us a negative. And you have the other case where you have a negative multiplied by a positive to give you a negative. So basically, we're just going to be replicating the outcome of this. So you have 4x minus 1, and we're just going to be doing this first case here. So we have a plus and a minus to give us a negative. And if we're doing this case here, what we're going to do is we're going to set this to be positive, right? So we're going to set our first factor positive, so greater than 0. We're going to set our second factor, x plus 5, less than 0. So now all we have to do is just isolate for x. So 4x is greater than 1, x is greater than 1 over 4, and x plus 5 is less than 0, x is less than negative 5. Now, what we do is we draw a number line. We have this here and this here, and we were going to put the lower number on the left, so we have negative 5. Again, it doesn't have to be like perfect, you're just drawing your numbers that you want to communicate. So we have 1 over 4, and what we're going to do is we're going to express the inequalities on this number line. So I'm going to set x is greater than 1 over 4 on this number line as blue, and the other one as orange. So let's graph the inequality x is greater than 1 over 4. So I'm going to do this. And we're going to find every point on this number line where x is greater than 1 over 4. So x is bigger than 1 over 4 when we go all the way over here. And then let's graph where x is less than -5. So any number less than -5, we're going to go left. So as you notice in case 1, there is no overlapping, meaning we have no actual solution here for our first case. But again, this is why we have our two cases, because we have our case 2 where we have a negative and a positive. So we're just going to set our factors negative and positive. So we've factored it to 4x minus 1 and x minus 5. So if we factored this so that it was 4x and minus 1, so what we have to do is we're going to set this one to negative. So to be negative means to be less than 0, and this one to be positive, which means to be greater than 0. So now we have 4x is less than 1, and x is less than 1 over 4. Same goes for here. You have x is greater than 5 when you add it. So now we're going to make our second number line here to express the other inequality. So I'm going to represent this one as blue and the other one as orange. So draw out your number line. Make sure your smaller number is going to be on the left. So you have -5 and you have 1 over 4. So any number that is greater than 1 over 4 is our first inequality here. So let's just draw any number that is greater than 1 over, or any number. Okay, so this inequality is any number that's greater than -5. So let's just shade right of -5. And now we have any number that's less than 1 over 4. So let's go left of 1 over 4. So as you notice, when we graph out the two inequalities, this gives us an overlap of sections, okay? So where it overlaps tells you what your answer to this equation is. So since we have an overlap between -5 and 4, or 1 over 4, you just put an x between these to represent this inequality. And now this is where we go back to our original equation. Remember, we had a less than or equal to sign. All we're doing is we're just bringing that back and putting it back into our final solution. So you have -5 less than or equal to x is less than or equal to 1 over 4. And this is going to be the solution to your first equation using case analysis. So you can actually write this as your domain. So x is such that -5 less than equal to x less than equal to 1 over 4. And x is an element of the reals. This is optional. You don't have to write it like this, but if you want to and it better resonates with you, you can definitely do that. So that is how you do it doing case analysis. If you don't get it, that's fine. We're going to be doing some more practice problems on it, so don't stress. I'll explain it more. So yeah, let's try the other method for now. So the other method is going to be using roots and test points, as so to speak. So I'm going to make this little chart here. Here, junk. And then I'll go across. Okay, so this is not going to be the best chart, but it is what it is. So we have our first is interval. And we have our second one as test points. We have our y value. Typically they give you this chart, but if they don't, it should be fine. Now you know how to graph it or make it out. Alright, so here we have our chart here. And we're going to be using roots and test points. So the way we do this is we have to find our roots. But if you remember from last equation, we got x is equal to -5 and 1/4. So we've already done half the process already. So again, with both methods, you're going to be using a number line. So make this little number line here. Again, it doesn't have to be the most beautiful thing. You're just graphing your two numbers. And yeah, don't worry about making it all pretty and everything. It should be fine, like realistically. Alright, so putting -5 on the left side and 1/4. And we're going to write out each interval of this line. So the first interval is going to be from this point to -5. And this is represented by any number that is less than -5. We have our second interval, which is going to be in between these two, which is just going to be represented by -5 less than equal to x less than equal to 1/4. And then we have our final interval, which is anything that's greater than 1/4. So you're just writing these three intervals of your line out here. So we have x is greater than, or x is less than, sorry, 5, -5, less than x less than 1/4. Then you have this last one over here, just going to be x is greater than 1/4. Alright, so now we're going to be doing a test point, right? So I'm going to go back to our original equation. So I'm going to select all of this crap and just get rid of it for now, because we've done our what we need to do with that number line. So now we're going to look at our equation, and we're looking for to actually plug in a point for each interval that makes it true. So any number less than 5, we're going to plug in back into our original line. So in this case, a number less than 5 could be like -6, right? So write that down, -6. And this side is going to be y. So whatever it outputs is going to be your y value. So 4 times -6 squared plus 19 times -6 minus 5 equals y. Now just put that all in your calculator. So like, you get 4x squared plus 19x minus 5. So when you plug that all in, that gives you a y value of 25. So again, we're just writing this down, and we're going to look at the sign of our y value. Since it's not a negative and it's a positive 25, we just have a positive sign here. Alright, so let's do this one. A number between -5 and 1/4. So I'm going to do 0, since the test point 0 is nice and easy. So 4 times 0 squared plus 19 times 0 minus 5 equals y. So y gives us -5 here. So we can write that. And since our sign is negative, write your negative sign here. And finally, you have your last interval that you want to fulfill here. So we're just using these test points. So any number that's greater than 1/4. So I'm gonna say like 3. We can use 3. Any number, you can use any number. I'm just gonna use 3 here, and we're just gonna plug it back into our equation. So we get 88 as our output. So if we have 88, we get a positive sign. And now we're done with the actual testing and everything. All we have to do now is we have to go back and look at our original equation. So we have this here, and you're going to notice how this is less than 0. Again, you're looking at your sign. Once you've done all your test points, you're looking at your sign and seeing what it actually means, right? Less than or equal to 0. Remember, this or equal to sign will transfer onto your answer. So to be less than or equal to 0 means to be negative, right? Because you're less than 0. So which interval gives us a negative output? The only one that gives us a negative output is going to be where -5 less than x less than 1 over 4. All we have to do is add our or equal to signs on the bottom, and then you box your answer. And that is how you solve using roots or test points. You're going to notice we have the same answers between the two using case analysis and using roots and test points. It's a matter of what you prefer and what you like best, but do know how to do both of them, because you will be using and you'll be tested on both of the subjects. Alrighty, so now we have this equation. I just want to emphasize how important like the inequalities part of this is going to be. I think it's very important that you nail this and get this down, because it's an important concept that you're going to be continuing to use throughout the course of Math 20. So just make sure you are very comfortable with doing case analysis, very comfortable with doing interval notation or interval and solving by roots and test points. So I'm going to do this equation by doing both roots and test points and interval just one more time to get it over it and get a final verdict here. So here in this case, we have our equation. So 2x squared minus 7x minus 15 is greater than 0. So to be greater than 0 means we're going to have a positive result. And remember, when we're multiplying, we get two factors of this equation. And if we have two factors, we're going to be multiplying them together, right? So what two things multiplied together give us a positive output? A negative and a negative, and a positive and a positive. And this is going to be different opposed to the negative one, where we had a positive and a negative, which gave us a negative output, negative and a positive, which gave us a negative output. So just make sure you're recognizing this and looking at the sign. So this is greater than 0. So right now, to solve this, we're going to have to set it equal to 0 to find the roots. So let's begin by finding the roots. So I'm going to do case analysis right now. Find roots. So the way to do this is we're going to factor this down. So I'm going to rewrite it over here. And we're going to set it equal to 0. So let's factor this down here. So we get two numbers that multiply to negative 30. Two numbers that add to give us negative 7. So there's a couple things this could be. Just remember, when we have a negative sign, our bigger factor is going to be the one that's negative. So in this case, I think we're gonna have negative 10 and 3, negative 10 plus 3. And notice how the negative 10 is bigger because we have a negative in front of our second sign. So now we can break down our middle term. So we're decomposing. So I'm going to put this 10x here, minus 10x in our first bracket. And we have our second bracket, which is going to be plus 3x minus 15. So now we can just look at what's common between what's common in the first bracket. So we have 2x. So we're going to factor out the 2x, and we're going to get x minus 5. And then 3 from the second one, and x minus 5. These two terms should match up. Collect these two, and you get 2x plus 3, x minus 5. You then solve for x, and you get x is equal to 5 and negative 3 over 2. Okay, and now that we found our roots, we're going to do case analysis. So remember, we're going back to this positive idea and negative. So we have our two factors here. We have this, and we have this. So we're going to draw our number line out. And this is going to be case 1. And this is going to represent the positive and the positive factors. So I'm going to set our first factor, I'm going to write out our numbers on the number line here. So we have negative 3 over 2. And we have 5 over here. Okay, now what we can do is we have our two factors, 2x plus 3. And we have x minus 5. So if we're setting both of these positive, we're going to set them both greater than 0. So now that we've set them greater than 0, we do 2x is greater than negative 3, and x is greater than negative 3 over 2. And then we're just doing the same thing for this other one over here. We're going to get x is greater than 5. So now we go over here and we're going to get x is greater than 5. So we're going to shade anything that is greater than 5 here for this first inequality here. And then for our second one, I'm going to represent it by using purple. So any number that is greater than 3 over 2. So we're going to go right of our number line here, and we actually have an overlapping section. The overlapping section happens where x is greater than 5. So that is going to be one of our solutions. So I'm going to write it up here. X is greater than 5 is one of our solutions. So for case 1, we're done. Now we're going to do our two cases, our second case here. So we have case 2, where we have a negative and a negative number. So just draw out your number line again and write out your roots. So we have negative 3 over 2 and we have 5. So again, we're just going to flip the sign here. So all you can do is, since we're doing the opposite of both, we're just going to flip the sign with each thing. And you get x is less than 5. But this is the same thing as going into it and setting it individually. Less than 0, x plus 5 less than 0. Because then you get x is less than negative 5, and 2x is less than 3, or negative 3. And then you get x is less than negative 3 over 2. So notice how it's the same when we just flip it around. You can do this when you have a 2 positive and a 2 negative. So yeah, basically we just said both of the factors less than 0 in this case, because we're representing this case where both of the factors are negative. So what we can do is now we can represent this inequality with our two colors. So I have where x is greater than 5, or x is less than 5, sorry. So this, and this should be pointing this way. Then we have where x is less than negative 3 over 2, so x is going to be, or our purple is going to be pointing towards the left. So now we have an overlap where the section negative 3 over 2, where x is less than negative 3 over 2. So this is going to be our second solution. So these are going to be the two inequalities, which net us two different results from our two different cases, right? So this is why we do case analysis. There's not always going to be one that gives you a no solution, but there are going to be times where you're going to have two different answers to your question. So now that we've done that, I can solve this using roots and test points now. So let's begin doing that. So to solve using roots and test points, we're going to have our first part, which is going to be interval. And then we have our second part, which is going to be our test point. And then we have our third, which is, we're just going to be looking for our sign. So that's what our table is going to look like. It's not going to be perfect here, but good enough. So we got our roots from earlier, if you remember, as negative 3 over 2 and 5. So let's just draw out our number line again. So you have negative 3 over 2 and 5. So again, with this, we're writing out our intervals of our number line. So all we have here is this first number line interval is going to be any number where x is less than negative 3 over 2. And then you have the second interval here where it's between 3 over 2 and 5. So you have negative 3 over 2 is less than x less than 5. And then you have your final interval on the right where you have x is actually greater than 5 here. So these are your three intervals of your line. So now we're going to do our test points. So if we're looking for a number that's less than 3 over 2 for our first interval, we could use like -4, for example. We're going to use the point -4 since that's less than 3 over 2. And all we're going to do is we're going to plug it into our line. So go in your calculator and plug in 3 over 2 or -4 for x, and then see what it gives you. And this gives us 45. So 45, and we're looking at the sign mainly. So the sign is positive here, so that's good. And we have this one where we have a number between x, or sorry, 3 over 2 and 5. So a number between 3 over 2 and 5 is going to be 0. So we just plug in 0 here. And that gives us -15. -15 is going to give us a negative sign. So we have this point as negative. So now we have to pick a number that's greater than 5. So I'm going to pick a number like 6 since that's nice and easy. So let's just plug in 6 into our equation and see what we get. So we get 15. And that gives us a positive number when you plug in -6, or sorry, 6. And that gives us a positive number. So basically, for this, we get a positive number where x is less than 3 over 2, and we get a positive number where x is greater than 5. And since our equation is looking for numbers that are greater than 0, we're going to look for the signs or intervals where we have a positive sign. So we have this and this. So these are going to be our two answers. So basically, where x is less than -3 over 2 and x is greater than 5 is going to be your answers. Again, it's going to be the same as case analysis. It's a matter of what you prefer and what you're most comfortable with doing. So just try to apply that, and you should be honestly fine. Using the graphing calculator to check as well is a good trick you can use. So I'll do this, and I'll show you how to check this using your graphing calculator. So we have y is going to be, we're going to pretend a 0 is y here. So we have 2x squared minus 7x minus 15, and we're going to set that greater than y. So remember that the y has to be on the left side, so we're just going to flip this here. You're going to get y is greater than 2x squared minus 7x minus 15. So now go in your calculator and type out your equation. So you have 2x squared minus 7x minus 15. So when we graph this out, normally it would just give us our line. And remember, when we're using less than, we're just going to be using this little bottom triangle here. So we're going to go down and we're going to use our bottom triangle, press OK, and then select graph. So now this is going to graph the inequality where the region is true. And you're going to see any point beyond -3 over 2 is shaded, and any point greater than 5 is shaded. So that's how you know you've done this correctly. If your answer was, for example, like in between, like you got this, you're looking for the graph to be shaded where it's in the middle. But since we got our points or our answers as any point that's beyond the parabola, beyond the parabola's arms, like this, we're looking for the shaded on the outside. So again, this answer will support the graph as well. So you're just verifying that when you graph this, it makes sense and it lines up with how your answer looks like. So again, since we have any point that is shaded beyond -3, that's our answer. And since we have beyond -5 shaded, that is going to be our answer. So we have done this correctly and successfully. And that's how you double check using your calculator. All right, so we're going to be doing this problem here where we have to actually make the opposite. We have to find the equation that models this line here. So if you're not given the points, usually you just find nice points that you can use. So when we're finding our vertex, again, we're just looking for this point here, the very peak of it. So you're going to need your vertex whenever you're trying to model an equation, but also you're going to need one of the two roots or a nice point on the graph. So like if this wasn't here and this didn't tell you anything, you could just find a nice point you could use on the graph. So like what I mean by nice, it's not like approximate. So like this point right here. So we have like 5 and 6 would be a nice point to use. So, but in this case, it does give us the point. So that's very nice. So again, this is going to be some unit 1 review almost, but with some of the new concepts that we've kind of learned. So what we have here is we're looking to model this equation, right? So we have ax minus b squared plus q. So we have the point 3, 8, and this is going to be our vertex. So it's going to be p and q. And since we have x-intercept, we have -1 and 0, and this is going to be x and y. So now we have enough information to actually plug this back into our equation and model what this parabola looks like. So y is equal to 0, so let's plug that in. We have a, which we don't know yet. Then we have x, which is going to be -1, minus rp, which is 3, squared, plus rq, which is going to be 8. So now we have a equals, so we have in brackets -1 minus 3, squared should be 16. So we have a times 16 plus 8 equals 0. So now we're just going to subtract 8 from both sides. I have -8 equals a to the 16th. And now you have -8 over 16 equals a. Or in other words, you have -8 over 16, which simplifies down to -1 over 2. So a equals -1 over 2. So now that we have our equation here, we have y equals -1 over 2, x minus our p-value which is 3, plus 8 as our equation that models this line here. So now what we can do is we're going to now determine what sign makes this true. So let's go back here and let's analyze. So if you notice this line here, it is dotted. And when we have a dashed line, that means that it cannot equal. So we're going to immediately remove 2 of these possible answers here. So we have this and this, because if it were or equal to, an or equal to sign, it would be a straight line, not a dashed one. So remember that, it's very crucial. So again, we're just going to go back and we're going to test either this point or this point. So whichever one you want to try, doesn't matter. So in this case, I'm going to be using y in place, or I'm going to be using y is less than in place of equals to just test which one is true. So we have x minus 3 squared plus 8. And now that we have this, we're going to try a test point, right? So looking at this graph, if we test the point 0, 0, we want it to be true because this region is shaded. So let's test the point 0, 0. So we have 0, 0, x and y. So we have 0 is less than -1 over 2, 0 minus 3 squared plus 8. So now we have 0 is less than. So now we have to plug all of this into our calculator. So we have 1 over 2 times -1 over 2 times -3 squared plus 8. And gives us 3.5. Since this inequality is true, because 0 is less than 3.5, this is going to be the correct sign to be using. So this inequality sign is the right one. If you were to use this sign, it would give you 0 is greater than 3.5, which is false. That's not what we're looking for. We're looking for the region for 0, 0 to be true, and this makes 0, 0 true. So this is going to be your final equation. So y is less than -1 over 2, x minus 3 squared plus 8. And that's how you do that. If this were a question where I was asking you to do a linear line, what you would have to do is you would have to find the slope. I'm not going to do a problem, but I will explain how to do this. So you have y2 minus y1 over x2 minus x1 as your slope formula. And then you're just solving for your slope. And then you'll get equation in mx plus b form. And then you're just doing the same process, right? If it's a dotted line, you can eliminate the or equal to signs. And you're just testing a point which has a shaded region to be true. So again, this might be like a question you want to know how to do. So understand this, practice this, and review to make sure you know how to do this. And you guys should be doing just fine. All right, moving on. Now we're going to be doing our word problem here. So we have a question that reads, Julia wants to plant a garden and surround it with decorative stones. She has enough stones to enclose a rectangular garden with a perimeter of 68 feet, but she also wants to keep her garden or to cover no more than 240 feet squared. So what could the width of her garden be? Solve algebraically using equations. Should be on a number line. Okay, so the way we do this is we're just gonna look at this, and since we have a rectangular garden, we're just gonna draw out a little rectangle here. And we know that our perimeter is equal to our length, and our length, and our width, and our width. So we have 2 length plus our 2 width is equal to 68 feet here. And she wants her garden to cover no more than 240 feet squared. So when we have feet squared, that's going to be usually in reference to area, right? So we have length times our width. And if it's no more, then that means that we're going to have at least, or our length and our width. So basically our area has to be less than 240, because we can't we can't overpass 240, but we can also be equal to 240 here. So this models what the question is asking for, where we have our perimeter equal to 68 feet, but also our length and width such that we don't go over our 240 feet threshold. So it's asking what could the width of our garden be. So to determine the width, you're going to find the x of this equation, right? So the way we do this is, if you remember back from unit 1, this is going to be very similar to you, because we've done these problems before where we have perimeter and we have area. So again, the way we do this, just for a little refresher here, is we have 2 length plus 2 width is equal to 68 feet, right? So now we want to isolate for one of our variables here. So you can isolate for width or length, doesn't matter which one, it'll give you the same result. So I'm just going to subtract, and I'm going to isolate for L here. So we have 2 length is equal to 68 minus 2w. We're going to divide everything by 2, and we're going to get length is equal to 34 minus w. So now that we've isolated for our w, we're going to plug it back into our other equation here, right? So we have length, which is now equal to 34 minus w. And we're going to multiply it by w. And we're going to set it less than or equal to 240. So now I'm going to distribute this. And we're going to get negative w squared plus 34w is less than or equal to 240. So this is the equation that models our inequality now. So all we have to do is we have to actually move this 240 to the other side as well. So you have negative w plus 34w minus 240 is less than or equal to 0. And now this is where you can use your case analysis to solve this. As we remember before, if we have something that is less than 0, that means we're going to be having a negative number. So if we have a negative, then that means we have both of our factors are going to be being multiplied. So one is going to be a positive and a negative. The other one is going to be a negative and a positive. Remember the two cases, right, with multiplication. So case 1 and case 2, respectively. So now what I'm going to do is I'm actually going to find our roots to this equation. So the way we can do this is we can do our case analysis here, or our quadratic formula here. So I'm just going to plug in our quadratic. So we think of 34 plus or minus the square root of 34 squared minus 4 times -1 times -240. And make sure this root goes all the way through. And then we have 2 times -1 on the bottom. So now, as we simplify, we get -34 plus or minus. I'm just going to put everything in my calculator here. So we have the square root of 34 squared. Or square root of 34 squared minus 4 times -1 times -240. What does that give us? It gives us plus or minus 14 over -2. So let's get our two solutions here. So our first solution is going to be plus 14 over 2. And you get -10. And your second solution is going to be the same thing, just minus. So let's subtract here. Divide this by 2. Or divide this by... sorry, this should be -2, so it's positive 10. And divide this by -2, and you get 24. So you get x is equal to 10, and x is equal to 24. Or in this case, w equals 10, comma 24. So now we're going to graph our inequality out on our case analysis. So we have 10, and we have 24, right? Remember, if we have x is equal to 10, x is equal to 10, and x is equal to 24. The way we can make this a factor so that we can do case analysis is we're just going to subtract 10 from both sides. So you just have 10 minus 24. Now you get x minus 10 equals 0, and x minus 24 equals 0, right? So we're just doing the opposite to isolate 0 on the right side. So now that we have our two factors, we can do our case analysis, right? So remember, we have our two cases. So the first one is going to be positive and a negative, because that'll output our negative number that we're looking for. So we have this, and we're going to set our first bracket less than 0 to make it negative. Or, less than 0 to make it negative. And then the second one, greater than 0 to make it positive. We're just setting one case positive, one case negative, or one factor negative. So now what we can do is we're just going to add 10 to both sides, and we get x is less than 10, and x is greater than 24 is our two inequalities. So I'm going to represent this with the orange, and I'm going to represent the opposite with the blue. So for the orange, we have x is less than 10. So we're just going to graph or make a shaded region for anything that's less than 10 on this number line. So that's what it's going to go left. And then we have anything that's greater than 24 on the other side of this number line. So we're going to have a number line that looks like this. And as you can see, this first case does not net us any solution. So now we're going to move on to case 2. So since we set our first bracket negative and the other one positive, we're going to do the opposite now. So we have a positive and a negative this time, right? So I'm just going to draw this number line. And we have our 10 and our 24. And now what we're going to do is we're going to do the same thing. So we have x minus 10. But this time we're going to set it greater than 0, because last time we set it less than 0. So that means we're setting this to be positive. And then we have x minus 24. And we're going to set that less than 0. So now I'm going to add 10 to both sides. I'm going to get x is greater than 10 and x is less than 24. So this is going to be represented by the blue and this one's going to be represented by the white. So now I'm going to graph this. So any number that is greater than 10 on this number line. So we're going to be moving right this time. And we have any number that is less than 24. We're going to be moving left on this number line here. So effectively, we're going to get this solution here of where between 10 and 24, we have our solution. So this is going to be represented by 10 is less than or equal to x is less than or equal to 24. And that is going to be your final answer here. But remember, since we have our w, we're just going to be using w in place of x here. And the reason we have our equal to sign is because our original equation has it. If it didn't, we would just leave it alone. Like, we would just leave it like this. But since we do have it, we're going to put it in. And basically what this tells us is that our widths can be anywhere from 10 to 24 to net an area that is less than 240, but still gives us a perimeter. Still give us perimeter combinations that will give us 68 feet. And this says the final solution should be on a number line for width. So this would be your number line for width here. So your case 2 would be your final answers. Alright guys, I think that's going to be it for today's video. I hope you guys enjoyed. I mean, it's been a lot of fun making these videos for you guys and, you know, just kind of explaining everything. If you guys want some more extra practice, I advise you do that. It's also encouraged that you're doing these problems. Like, you're pausing the video, you're going through it, and you're doing it. That's what I encourage you guys to do. But yeah, if you guys want some extra practice, just let me know. I'll make some more on word problems, perhaps. But otherwise, good luck, everybody. I hope you guys do well on your test. I hope this video helped, and goodbye.